When the skies darken during the total solar eclipse on 8 April 2024, colors will change and some stars and planets will be visible in the daytime. Here's what to look for and where. An observer in or near the path of totality for the solar eclipse may be witness to many unusual phenomena, including the appearance of the moon's shadow projected on the Earth's atmosphere and darkness during the daytime. For the upcoming eclipse, a few minutes before the start of totality, a conspicuous shadow should appear, mimicking an approaching storm, moving from the west-southwest sky and toward the observer. Darkness will follow, and with it the chance to see stars, planets, and possibly other bright objects in the daytime sky. For those witnessing the total phase, the moon's shadow overhead appears a dusky blue if there are no clouds, and the light from outside its edge forms a bright border around the horizon. The saffron tint of air outside an eclipse shadow may be especially impressive, since air scatters long wavelengths of light. Less than short, the light from outside the shadow is yellowed or reddened, the exact color depending on the distance from the shadow edge to the observer. At 50 miles or more, the bright reddening glow is pronounced and the bright tawny glow is low. Since at the upcoming eclipse, one can be as far as 50 to 60 miles 80 to 100 kilometers from the shadow's edge. If positioned on the center line of the eclipse path, some vivid colorations may be evident, especially toward the northwest and southeast at mid-totality. Outside the path of totality, even at a considerable distance, the moon's shadow can sometimes be seen projected against the atmosphere. At the eclipse of 9 July 1945, the shadow was seen near the horizon from Portland, Oregon, 320 miles 515 kilometers west of the point where the eclipse was first total at sunrise. Also, at the eclipse of 2 October 1959, which was total in eastern Massachusetts, the shadow was visible on the northeastern horizon to an observer only 15 miles 24 kilometers northeast of New York City. The smaller the distance from the path of totality, the better the chance of seeing the shadow. There are several methods of observing the degree of darkness at mid-eclipse. One way is to note the smallest size of newsprint that is legible. This can be done even when the sky is overcast, but the type and extent of cloud cover should be carefully recorded. Also, useful and even better than visual techniques are good all-sky photographs using a fish-eye lens or wide-angle convex mirrors or photometric measurements with photoelectric meters. A second way is to note the faintest star or planet visible. When the sun is totally eclipsed, the sky does not, as many astronomy guidebooks suggest, appear as dark as a moonlit night. Rather, it gets about as dark as it is about 20 to 40 minutes before sunrise or 20 to 40 minutes after sunset. In such a sky, Venus is usually very conspicuous, and other bright planets and first magnitude stars near the sun have also been reported. Venus by far will be the brightest object at visual magnitude 3.9 in astronomy. The lower the magnitude, the brighter the object. On eclipse day, it will be positioned about 15 degrees to the west lower right of the sun. There will be other planets around, but it's debatable whether they will be readily visible. Saturn and Mars will be, respectively, 35 and 36 degrees to the west of the sun. Little Mercury will stand a half dozen degrees to the east of the sun, but at a very faint magnitude, so it will be invisible. So far as stars are concerned, eclipse will give you a fine opportunity to gauge the brightness of the sky, since the bright stars of the winter season will be well placed across much of the eastern part of the sky. Load toward the east-southeast is Sirius, the brightest of all stars at magnitude -1.5. If, however, you are located along the totality path in Texas or Mexico, you won't see it because it will be below the horizon. Capella will be high in the east-northeast, while Rigel will be much lower in the southeast. A few fainter stars of the first magnitude may appear here and there, but the light of the corona, the sun's outer atmosphere, as well as the general scattering of light filtering in from outside of the umbra, will quench most of the stars. But perhaps using your totality time to try and pick out stars and planets is not the way to go. This might be the best piece of advice for anybody who intends to observe the spectacle of a total eclipse of the sun. So remember, should you get your chance at one indeed, just look at it and enjoy it. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.